Here's a quick video relating to GIS Project 2. GIS Project 2 is going to be a lot like GIS Project 1. It's basically going to be using a lot of the same skill set. Now that you've done it once, it shouldn't be bad at all to do a lot of those same skills again, but with different data. Okay? Repetition is always great when you're learning software, when you're learning to work with quantitative data like this. So for this one, what you're going to do is you're going to pick an urban area of your choosing and construct a tract level data set. So I'm going to show you Kansas City, for example, the urban area of Kansas City, but it's going to be a tract level data set. And it's your choice whether you want to use the selection criteria of tracts that have their centroid in, or whether you want to do the intersect with. That's demonstrated in some of the GIS tutorial videos, and then kind of refine that manually if you want. But you're ultimately going to want a tract level data set for that particular urban area. Okay? You'll also want to see if the resulting tracts are fully within a single state or whether those tracts span 2 or more states. This is relevant information for when you download additional data that you're going to be adding to those tracts, right? You're constructing a data set. Okay? So once you have those tracts, and once you know whether they're all within a single state or whether they span 2 or more states, then you're going to want to go about getting the data that you want to join to those tracts. And joining data from 2 different areas. One is the life expectancy data that the CDC has recently created at the tract level. It's actually quite difficult to calculate life expectancy, particularly at what they call small area as low as tract level. So this is relatively new data that came out last year or 2. And so we're going to get that data, we're going to join it to our census tracts. Now these estimates are based on mortality life tables from 2010 to 2015, right? By aggregating multiple years of data, they have enough data to create or to generate estimates of life expectancy at the tract level. Okay. Now obviously, given that life expectancy is based on data from that time period, we're also going to want American Community Survey. This will be where we get our sociodemographic data. We're going to be using the 2011 to 15 5-year estimates. And then from there, depending on your city or urban area, you can use whatever race, ethnic composition variables you feel are appropriate for your urban area. And then you want median household income and percent impoverished as well. Okay, so you should be able to know how to get all of those. And then again, if your tracts for your city span 2 or more states, you're going to want to have to append the data from the relevant states in Excel, particularly for the life expectancy. It's already done in American Computer Survey if you do it right. But for the life expectancy, you want to append that in Excel, and I'll illustrate that. Okay. One other thing to keep in mind, and I'll illustrate this as well, is that after you've joined the data from these 2 sources to your census tracts, before you bake that data, I want you to save it as a layer file, and then I want you to use that layer file as the basis for your maps. Why do you do that? Because once you bake the data in there, any data that's missing gets turned to zeros, and ArcMap will try to map it as zeros, and it's kind of complicated. But if you save it as a layer file, layer files respect missing data as missing, and that's what you want. Unfortunately, we still need to bake the data because we need to create that final data set, that DBF file that has all that data permanently joined, and that's what we need to import into Stata. So in that baking process, you will have all your missing data turned to zeros, but we can deal with that in Stata, and we'll convert those back to missing. Okay. Now the end product of here is going to be just sort of another little poster kind of thing, similar to the first, but you won't need to do the intro and concluding paragraphs. I'm not interested in you needing to do that more than once. But you'll still have some maps, well-formatted, graphs, and correlations, and a brief kind of talk through of what you see in those results. Okay, very brief. Okay, again, just sort of see this as an opportunity to keep exercising those skills that you started to develop. Okay, so let's see what this looks like. So I've already created my Kansas City census tracts. And what I want to do is want to see, do these census tracts span more than one state? So I brought in the state layer file as well, and there it is on top. If I click on that little box and make them hollow, and then I'm just going to make the outline really big, you'll see that my urban area census tracts span 2 states. In this case, it's Kansas and Missouri. Now, most cities, you might not have that issue. Most of them probably be in a single state, but some of them will span 2 states and maybe 3. So you're going to want to keep track of that and make note of which states you have to deal with. And again, if you need to label the states, you can see what they are. Okay, so you just kind of keep that in mind as you move forward. I'm not going to need that anymore. So now we need to go get the data. So we already know where to get the American Community Survey. You just pull up Chrome and go to Social Explorer. And we're going to go to Tables. We're going to do the 5-year estimates for ACS, and we want the data 11 to 15 is about the closest we're going to get to the life expectancy data that we'll be getting. So we're going to get tract level data. And now that since I'm doing tracts in multiple states, I'm going to have to first start with Kansas and get all census tracts in Kansas, add those, and then I'm going to go and get them for Missouri. All census tracts in Missouri. Proceed to table, and then let's see, we're going to do Hispanic or Latino by race. Scroll down and get to median household income, and then we'll go down to the poverty data. And what we're going to do here is we're going to get ratio of income in 2015 to poverty levels summarized. Okay, and then we'll add that. Did I not get the, I'm not seeing the race. Let me go back and make sure that's added in there. Hispanic. Okay, so now they're all added in there. We'll show results, and we'll go to data download. Always check these 2 boxes. It already calculates the percentage for us, which is nice. Open that Excel file. And of course, we're going to want to clean this up quickly. So I'm just going to change that to FIPS, get rid of all this excess stuff. Okay. We do want the pop tote, or total population, so pop tote. We don't need the other one. You know what, I'm just going to go down to the percentages because I'm only really interested in the percentages. If I was doing a more thorough job, I might keep a lot of this stuff. But ultimately, I want, for Kansas City, I'm going to look at percent white, percent black, and percent Latinx. So I'm going to do P white NH, P black NH, let's scroll across, there's P Latinx, okay? So I want total population, and then those percentages. Again, depending on your city, you might want to use different groups, okay? And again, if I wasn't doing a quick job on this, I would probably keep even more groups, but I'm just trying to do this for illustrative purposes. There's median household income. I'll change that to MHI. And then for these, we just need the poverty, percent impoverished. So it's that first one here. That becomes our PPOV. Get rid of the others. Okay. And we can expand that. And we can name this sheet something else. We'll call it ACS 1115. And then we'll go File, Save As. I'm going to save it to my student Wade Roberts GIS Project 2 folder, which I already created. And I'll call this ACS and save. Say yes, and then close. And at this point, you just say don't save. Okay, so that's how you get the ACS data. Now let's go get the CDC data. So just going to pull up a clean Chrome, and then you just type in CDC life expectancy, and then I usually throw in the words small area just to make sure it takes me to the right web page. What you're looking for is this NVSS web page. Okay. So it's USA Leap kind of thing. So you can read a little bit about this project and the methods and things like that, but the data is down here, and it's all broken out by state. Now they do have a US one, but I wouldn't use that. Even though that's life expectancy by census tract for the entire US, I believe it includes state life expectancy as well, and that just messes things up as well. So I would just use the state data. Now, so I'm going to need Kansas and Missouri, so I'm going to download those. Now, if you happen to be doing New York and you're using the urban area for New York, it really spans New York and New Jersey. But the other thing I would point out is that there is a special exception where they actually have New York City as its own thing. So you'd have to throw that in as well. Doing New York and New Jersey wouldn't be enough. You'd have to throw in New York City as well. Okay, I think that's the only exception. And obviously DC, District of Columbia, is its own thing. So I'm going to need Kansas and Missouri, so I'm just going to click on each of those and do the life expectancy CSV file. We're going to do Kansas, just click on that, and then Missouri. They both download right here. And I'll just open Kansas first. What I'm going to do is I'm going to basically copy and paste the Kansas data to the Missouri data. I'm going to append it. So I just want one Excel file. So what I'm going to do is I'm going to just put the cursor in the first data cell right here, and then I'm going to navigate down to the bottom right cell, and while I'm holding down the shift key, I'm going to click in that bottom right cell. That highlights all of that data. Okay, I'm going to copy, and now I'm going to go back to Chrome and I'm going to open up the Missouri data. And I'm going to scroll all the way to the bottom of the Missouri data. And then I'm just going to put the cursor there, right click, and paste. So basically I've just appended, notice how the FIPS changes because we have different states, it goes from 29 to 20. Okay? But I just appended all of the Kansas data to this single one. Now we can clean this up again. I'm going to change this to FIPS. Now we don't need these B, C, and D. I can get rid of those. Now E parentheses 0 is actually your life expectancy estimate. I'm just going to call that expect. The SE stands for standard error of the life expectancy. So this is just an estimate. And they've been able to calculate a standard error, or sort of a margin of error, if you will, for that estimate. But we're not going to deal with that for now, so we're just going to get rid of all of those. So just a pretty simple data set. Okay? And I'm going to change this sheet just so it says KSMO. And then I'm going to file save as. And I'm going to save it to my folder. This one we'll call expect CSV, save. Oops. Let's try something else. Let's try life. I don't know why it's giving me an error, so we'll tinker around, we navigate, students, wage, GIS project 2, let's try it again. Okay, it worked that time, I don't know why. I had previously created a project 2 folder and then deleted it to start fresh for this video, so that was probably it. So yes, keep the format, then close this, and don't save. And then we can close the other one as well, we don't need to save that. We can close that. Okay, so now we can bring in our data. And navigate to my students folder, project 2. There's my ACS data, and then I'll bring in the life data. Okay. Now, of course, we need to join those. They're both based on FIPS, so we'll do join. FIPS 2 is already in there. FIPS, and then do it again. Join FIPS 2 again, and it's already picking life, and hit OK. Okay, so we've got our data joined softly at this point, but before we bake, and this I want to point this out, and I said this earlier when I was introducing the project, before you bake, I want you to right-click and save as a layer file. Okay, and make sure that navigates there, and just go ahead and hit save. Okay, so this layer file is what you can use to do the formatting, and it preserves missing data. What you'll find out is that sometimes there are missing tracts that don't have life expectancy estimates, and we don't want them to show up as having a 0 or something like that. So we'll want to use that layer, and I'll show you that in a second. But we'll also want to now export this data on itself and create that baked version. That creates, I'm going to call this, final data, shapefile, hit save. Hit OK. And I don't need to add it. I only needed to create it because I need that DBF for Stata. Now, I'm going to remove all of this stuff, I want to show you what that layer looks like. Right? So there's the, navigate back here. Here's that KC tracts layer. And now if I format that, let's say I do the life expectancy, there's expect at the bottom, you'll notice I don't have a 0. Okay. But you get these white spots. Okay. But that's where you don't have any data. So if I actually used the final data one, notice what happens with that baked version. If I do expect, notice I've got a 0 and it fills in everything. And so that just messes things up when you're trying to do maps. Okay. So we needed to make that shapefile, but that final data shapefile, but only for Stata purposes. So we are going to open up Stata then. And I'm going to leave the map making to you, all that stuff. Once you're in Stata, of course, you need to file import the data, and it's a DBF file. That's the attribute table. Navigate to your folder. Oops. Students, Roberts, project 2, and there's the final data. Okay. And we'll bring it in. Now, again, this data resulted from the baking process. The baking process, unfortunately, turns missing data to zeros. That's problematic when we're dealing with any of our census data that should be missing or our life expectancy data. Now, I obviously know that you shouldn't have a 0 life expectancy in any tract. So if I do the sum command and expect, you'll see that the minimum is 0. So clearly, some missing data got turned to 0. And in fact, if I look at the histogram, you'll see that a number of the tracks load on 0 over here on the left rather than being out here where they should be. So here's the command to switch those zeros for life expectancy back to missing. And in Stata, the missing value is a period. Okay, so the command is simply replace expect equals period if expect equals, and there's 2 equals on that second one, 0. Okay, so just process that for a moment. Basically, replace the variable expect with a missing value, period, if expect is currently 0. So anytime you have an if command, you have to do 2 equal signs afterwards. Okay, so that takes care of the issue with the life expectancy, but we also have these demographic ones. Now for those, I don't want any, now it's possible that you could have 0% white non-Hispanic or 0 P black NH and so on. But you shouldn't have that if population total is 0. There should actually be missing in that case. So what we're going to do is for all those demographic ones from the ACS, I'm going to replace P white NH equals missing if pop tot equals 0. Okay. So if there's no population, they shouldn't have a percentage on what, percent white. They should be missing. And I'm going to do that for all of the demographic ones in this case. So equals missing if pop tot equals 0. And then replace P Latin X equals missing if pop tot equals 0. And replace MHI equals missing if pop tot equals 0. Go slow. You don't want to, like I almost made a mistake and put MHI equals 0. Don't want that. So replace P pop is missing if pop tot equals 0. Okay? Notice, again, all your ACS-based variables use the if pop tot equals 0 to switch back to missing. Okay? So once you've done that, feel free to go ahead and file save as that data. So this could be Stata 2. And then at that point, you can do the kinds of analyses you know how to do. You can calculate Pearson's R correlation coefficients. You can do scatter plots and fitted lines. One other interesting graph, if you like it, is to go to graphics and do the scatter plot matrix, where you can put in all of your variables. So let's say I do expect, and I like to put the outcome, life expectancy, first. And then we can do P white NH, P black NH, MHI, and P POV. I would do the marker properties. I would set that to tiny. You might have to end up go back and do very tiny if you have a lot of census tracts. And then just go ahead and OK. And what you do is you get sort of a lot of the scatter plots. Unfortunately, you can't put fitted lines in there at the same time, but you can clean this up. So if you like this, you can click on expect here and change it to life expectancy. Hit return, otherwise it doesn't take. Same thing here, right? You just change it up here. And then the same thing about these X labels. You have to just go to Access Properties, Label Properties, format them as fixed to numeric, and you should just be able to hit OK at that point. Just makes them cleaner. So you just have to do that for all of those fixed. It's already there, but if I hit OK, and hit OK, fixes those. So you can fix all those up and you can add titles. That's if you like that. Now again, how do you read these scatter plots? It's as, for this one, as percent white non-Hispanic goes up, life expectancy goes up. As percent black non-Hispanic goes up, life expectancy tends to go down. As median household income goes up, you see a rather precipitous rise in life expectancy. It tails off once you get to about 100, 120,000. Okay? And then as poverty rate goes up, life expectancy goes down. And then you can sort of see, obviously, the relationship between some of these others. So, for example, as poverty rate goes up, what happens with African American population? You can sort of see there's that positive association in that case. Okay, that's just another one in which you can play around if you want. Okay, so that's how you do Stata. And again, get back to the overall project. Don't lose sight of the bigger thing. You are tasked with basically doing a urban area level, tract level data set. And you have to construct that data, and you're pulling data from different sources, you're prepping it, and you're joining it, and you're making maps to illustrate any of those associations, or the spatial patterning of life expectancy, and then of course the spatial patterning of different demographic variables. But then you have the ability to do scatter plots and correlation coefficients for any of those relationships. Okay?